It began with a silence, not the absence of sound, but the suspension of meaning. A silence so profound that even the instruments orbiting Earth could not interpret it. Waves of data returning from the void, encrypted in patterns that defied noise yet refused coherence. For months, the research teams at the European Southern Observatory dismissed it as cosmic interference. Then, when the signal repeated not identical, but eerily recursive, the silence acquired a heartbeat. At first it was faint, like the whisper of radiation lingering from the birth of the universe. But its geometry betrayed its symmetrical pulses, logarithmic spacing, a structure too deliberate for chance. The James Webb Space Telescope triangulated the source somewhere between the outer edges of the Oort cloud and the interstellar medium, a region of space so empty that even light moved there as if uncertain. The data formed sequences self-similar, recursive, fractal in their decay, not a language, not mathematics, but something in between. Scientists debated its nature: quantum resonance, relic radiation, or an artifact of instrumentation. But in the pattern's harmonics, a linguist at Cambridge recognized the improbable resonance corresponding to the nucleotide pairing frequencies found in terrestrial DNA. The universe, it seemed, was humming the same melody that constructs life. The discovery shattered the quiet arrogance of isolation that had defined Earth's self-image. For centuries, humanity had stared at the night sky, confident in its exceptionalism. Yet now a question older than any civilization rippled through every observatory, every laboratory, every contemplative mind. Could life itself be an echo, transmitted across cosmic epochs, awaiting the right conditions to awaken again? In the laboratories of Geneva, deep beneath the Earth, particle physicists spoke of entanglements that transcended space and time. Geneticists whispered of sequences that appeared too perfect, too efficient to be products of pure entropy. And in the deserts of Chile, a researcher studying ancient microbial fossils found isotopic signatures suggesting that the building blocks of life predated the planet that carried them. Carbon that should have been young bore the mark of stellar antiquity. Every discovery was a mirror turned inward. The closer humanity peered into the cosmos, the more it seemed to glimpse its own reflection staring back, vast and indifferent. The narrative of life as an accident began to fracture. There was a symmetry and elegance that haunted the equations, as if the universe were predisposed toward the emergence of consciousness, as if intelligence were not an anomaly, but an inevitability. Physicists spoke cautiously of fine-tuning the balance of fundamental forces, the improbable stability of hydrogen, the narrow temperance of habitable zones. Too perfect, said some, just enough, said others. But a few began to suspect that perfection and coincidence were merely the vocabulary of ignorance. In that growing silence between knowledge and wonder, the enigma deepened. A research probe orbiting Titan detected traces of nucleobases embedded in frozen hydrocarbons: adenine, guanine, cytosine, thymine, the same molecular alphabet that composes human DNA, preserved beneath an alien sky. The implications were unthinkable. Either life was a universal template woven into the very physics of creation, or it had spread deliberately, carried on cosmic winds from world to world like seeds cast across a galactic field. For every discovery that drew the universe closer, another receded into abstraction. The cosmos was both infinite and intimate, cold and alive. Observatories became cathedrals, equations prayers. And science, once a method, began to resemble theology, except this time, the god it pursued was information itself. Philosophers revived forgotten questions: if life emerged everywhere, was consciousness the mechanism through which the universe observed itself? Was awareness not a property of organisms, but of matter striving to recognize its own pattern? If so, the human mind was not an origin, but an iteration, a single note in an unending fugue of being. And then came the Antarctic find. Beneath 3 kilometers of ancient ice, a meteorite was unearthed, its interior sealed since the dawn of the solar system. Within it, molecular traces formed crystalline helices, mirror images of Earth's own genetic structures, but reversed. Their chirality, the handedness of their chemical geometry, was opposite to all known life. A world turned inside out, an echo distorted through time. The molecules were ancient, older than the planet, and yet they whispered familiarity. It was as if someone or something had written the code of life twice, in 2 directions, across 2 epochs. The implications rippled through every field. If these mirror molecules had once flourished, their extinction would not erase their legacy, it would merge it. Perhaps life on Earth was not original but recombinant, a fusion of two ancient lineages, one terrestrial, one cosmic. The press called it the twin genesis, theologians called it blasphemy, but among scientists a quiet terror took hold. Because if the same genetic signature appeared independently in multiple corners of the cosmos, then evolution was not a random walk, it was a recurrence. Life, given enough time, would always rediscover itself. And if that was true, then perhaps Earth was not the beginning of intelligence, but its reawakening. Somewhere beyond the reach of light, an ancient experiment might have succeeded, then vanished, leaving behind the simplest messenger, a seed that could endure extinction and begin again. The astronomer who first traced the signal's geometry compared it to the Fibonacci sequence. The universe, she said, doesn't speak in words, it repeats itself in patterns. In the quiet corridors of the Max Planck Institute, an old astrophysicist stared at the data rendered across his screen, the pulse, the symmetry, the DNA resonance, and whispered to no one it is not trying to communicate. It is remembering, and perhaps that was the most disquieting revelation of all, because if the universe could remember, it implied that something had happened before, something vast, something sentient. What if Earth itself was not the cradle of life, but its tombstone? What if everything that breathes, speaks, or dreams upon it is merely the echo of a civilization that the stars have already forgotten? And if that were true, if consciousness is only the residue of an older mind scattered through the cosmos, then the question is no longer where we come from. It is who remembers us. For centuries, the story of existence has been told in a sequence of explosions and accidents. It begins with nothing, and nothing so dense, so absolute, that it defies comprehension. Then a rupture, a singularity unraveling into light, time, and geometry. The Big Bang, the first exhalation of the cosmos, setting in motion a chain of inevitabilities that would, billions of years later, produce oceans, eyes, and thought. The early universe was not made of stars, but of chaos plasma, seas of quarks and electrons, a turbulence of raw potential. Gravity, that silent sculptor, began to gather the dust of nothingness into islands of form. Galaxies swirled into being like luminous storms, their centers collapsing into invisible hearts, black holes, where time curved back on itself. Around these cosmic furnaces, hydrogen birthed helium, helium birthed carbon, and the slow alchemy of stars began to write the periodic table upon the fabric of reality. Everything that lives was first forged in fire. Carbon in the lungs of supernova, oxygen from dying suns, iron, calcium, phosphorus, each element a memory of a stellar death. To exist, we first had to be burned. The universe became an immense crucible, each explosion a note in a cosmic symphony of matter becoming mind. From the ashes of ancient stars, planets condensed. Dust turned to rock, rock to water, and water to chemistry. The early Earth spun through its fiery adolescence, molten, hostile, smothered in storms of methane and ammonia. Lightning raked the primordial seas, fusing simple molecules into the first precursors of life. This was the creed of abiogenesis, that given enough time, energy, and randomness, inert matter would stumble into awareness. Scientists called it the self-organizing miracle, the improbable transition from molecule to metabolism. Experiments in sterile laboratories recreated fragments of this process. Under the right conditions, amino acids assembled spontaneously, lipids formed membranes, and chains of nucleotides began to copy themselves. Life, it seemed, required no architect, only patience, chance, and chemistry. From that foundation, evolution took hold. Random mutation and natural selection became the twin engines of creativity, sculpting endless forms from the blind play of survival. Through the long corridors of deep time, single cells learned to cooperate, to specialize, to think. The tree of life spread across continents and oceans, culminating in one small corner of one small planet, in a species capable of asking where it came from. The cosmic narrative was elegant, almost comforting. The universe began in simplicity and grew toward complexity, as though intelligence were an emergent property of chaos-seeking symmetry. For the modern mind, it was enough no gods, no ancient architects, only matter arranging itself into consciousness through the slow arithmetic of physics. The Big Bang Theory stood as the unifying origin story. Microwave background radiation confirmed its echo. The expansion of galaxies proved its persistence. The universe was finite in age, infinite in mystery. And yet, within this model, everything followed rules, immutable laws, predictable constants. The cosmos, though vast, was comprehensible. Astronomers mapped the cosmic web, a lattice of galaxies connected by filaments of dark matter, stretching across the observable universe like the neural network of some sleeping mind. Physicists measured fluctuations in the cosmic microwave background, tracing them like fingerprints of creation itself. Chemists reconstructed the birth of organic molecules from interstellar dust. Biologists retraced evolution step by step, from stromatolites to sentience. The prevailing belief was that humanity had inherited a silent universe, a theatre of empty spaces and cold stars, indifferent to the drama of life that flickered briefly upon one blue planet. Intelligence was seen as local, transient, and emergent accident in a universe that neither demanded nor noticed it. To believe otherwise, to suggest that consciousness might be more than a biochemical illusion, was to trespass beyond science into the territory of myth. Rationality was the creed of the modern cosmos, a world without meaning beyond the one it manufactured. Even the most intricate mysteries could be reduced to equations. Gravity explained orbits, thermodynamics explained entropy, and quantum mechanics explained uncertainty. Everything ultimately could be measured, modeled, and predicted. The dream of total comprehension was the cathedral of the modern age, but beneath the symmetry of this world view, small fractures began to appear. The fine-tuned constants of nature, the delicate balance of the strong nuclear force, the precise ratio of matter to antimatter remained inexplicable. Why did the universe choose conditions so narrow, so exquisitely fragile, that even the slightest variation would have made life impossible? Some dismissed the question as meaningless. We observe these constants, they said, because we exist in a universe where they allow observers. But others heard in that reasoning a circular whisper, an evasion cloaked in logic. In the laboratories of particle accelerators, the vacuum was not empty. It teemed with virtual particles flickering into and out of existence, ghostly reminders that nothingness itself was pregnant with potential. Space was not absence, but fabric, and perhaps fabric implies design. The more science illuminated, the deeper the shadows it revealed. Dark matter, invisible yet dominant, shaping galaxies. Dark energy, unseen yet accelerating the universe's expansion. The cosmos was composed mostly of things that could not be seen, measured, or understood. The known, it turned out, was a small island adrift in an ocean of mystery. Still, the orthodoxy held, life was an accident. Consciousness an epiphenomenon, the universe a grand but indifferent machine. The narrative was stable, coherent, and functional. It gave order to the chaos, predictability to the unknown. And yet every generation of scientists carried a hidden, uneasy suspicion that their equations described the how, but not the why. The Big Bang explained the birth of time, but not its cause. Abiogenesis described the emergence of life, but not the spark that animated it. Evolution accounted for adaptation, but not for awareness. As the instruments grew sharper and the telescopes more powerful, humanity's reach extended to the edge of the observable cosmos. But the deeper it peered, the more the familiar laws began to blur. The expansion of the universe appeared to accelerate as though driven by something beyond comprehension. The fabric of space twisted around massive objects in ways that suggested an unseen geometry. And then there was the question of time. According to general relativity, time was not a constant but a variable, elastic and relative. To an observer near a black hole, a moment could stretch into eternity. The universe was not a linear story, but a looping structure where beginnings and endings might be indistinguishable. Yet the human mind persisted in craving a narrative, a beginning, a middle, an end. The Big Bang was the beginning, entropy would be the end, and in between, the miracle of consciousness would burn briefly, like a candle in the cosmic wind. That was the model, that was the creed. But what if it is incomplete? What if the universe is not a closed equation, but a recursive phenomenon, one that remembers itself through matter, repeating cycles of creation and dissolution? What if life did not arise once, but many times across countless worlds, not as an exception, but as the rule? And if that is true, if the cosmos itself evolves through memory and recurrence, then perhaps the Big Bang was not the beginning at all. Perhaps it was simply the latest breath of something that never truly stopped breathing. The first contradiction arrived quietly, almost apologetically, as if the universe itself were reluctant to interrupt its own narrative. In a remote observatory in the Atacama Desert, astronomers studying faint signatures of light from early galaxies found something impossible: mature structures forming too soon after the Big Bang. According to the equations, there should have been only chaos, then no stars, no ordered systems, only the hot plasma of the young universe still cooling into form. Yet there they were, ancient galaxies shining with the heavy elements of long-dead stars, as though time itself had started earlier than it should have. The data from the James Webb Space Telescope confirmed it. Massive galaxies 10 times older than their epoch allowed emerged in defiance of cosmological models. The timeline of creation had fractured. The universe appeared to have grown too quickly, as if it were remembering rather than inventing its architecture. At first, cosmologists blamed calibration errors, data processing artifacts, illusions born from gravitational lensing, but the evidence multiplied. The early universe, they discovered, was not the dim and formless expanse predicted by theory. It was organized, structured, mature. The cosmic dawn looked more like a memory than a beginning. It was not the only discord. Deep beneath the Pacific, microbial fossils dating back 4 billion years revealed complex biochemistry that should have been impossible in such a young biosphere. Their isotopic ratios implied not just metabolism, but photosynthesis, a process requiring intricate molecular machinery that, by evolutionary standards, should have taken hundreds of millions of years to evolve. Life, it seemed, had appeared not as a hesitant experiment, but as a recollection, as though it already knew how to be alive. In the laboratories of Oxford and Kyoto, molecular geneticists sequenced ancient microbial genomes extracted from permafrost and meteorite residues. What they found was stranger still: conserved genetic motifs, small segments of code that matched no known species, yet displayed mathematical patterns eerily consistent across all terrestrial life. These were not random mutations. They resembled compression algorithms, fragments of data optimized for storage and replication. Nature, it appeared, was encoding something that predated even the cell, but where could such an inheritance come from? Evolution, by its own definition, does not remember. It adapts, it discards, it forgets. Then came the discrepancy in the cosmic microwave background, the afterglow of the Big Bang itself. For decades, physicists had considered it the most pristine evidence of the universe's infancy, a perfect map of its early fluctuations. Yet new high-resolution analyses revealed asymmetries, cold regions and hot spots arranged in configurations that implied directionality, as if the universe bore scars of prior events. Some even detected faint circular imprints, concentric rings that might, according to controversial models, be echoes of collisions between universes before this one was born. The consensus fractured. Some argued these were statistical anomalies, others saw the fingerprints of pre-existence. The universe, once thought to be a blank slate at its inception, now appeared to carry residual patterns and inheritance written into its very geometry. Still, science persisted in its denial. The standard model of cosmology had survived too much to surrender to suggestion. But denial in science, like entropy in physics, is never permanent. A group of astrobiologists at the European Space Agency published a study on interstellar organic molecules detected in the tails of comets. These were not simple hydrocarbons, but complex chains of amino acids arranged in specific sequences, peptides formed in environments too cold for chemical synthesis. The ratios of isotopes suggested an origin not in the solar system, but in interstellar dust clouds billions of years old. If these molecules had drifted through the galaxy long before Earth existed, then the seeds of life were not local phenomena, they were cosmic refugees. That alone might have been explainable, but what unsettled researchers most was the chirality. On Earth, life favors one orientation of amino acids left-handed. In comets and meteorites, the same orientation prevailed, an inexplicable coincidence, unless both shared a common ancestry. Somewhere, long before Earth coalesced from stardust, the blueprint of life had already been written, and the universe had never stopped copying it. In the quiet hours of night, when telescopes turned toward the dark between stars, radio astronomers began to notice peculiar interference patterns in the cosmic noise. They were not signals, not in any human sense. But the noise itself seemed structured entropy with intent, random sequences arranged in harmonic intervals, reminiscent of musical overtones. It was as though the background hum of the universe were modulated by an unseen hand. The pattern repeated every few months, aligning with the orbital cycles of certain exoplanets. Coincidence, perhaps, or resonance matter vibrating in sympathy with something older, deeper, and vastly more intelligent. The contradictions accumulated like errors in a simulation. Each discovery eroded certainty, each anomaly a whisper of something larger observing from beyond comprehension. Yet none of it fit neatly into the language of established science. The laws still held, but the context was shifting, as though gravity and evolution were secondary effects of a principle yet unnamed. Philosophers of physics began to ask forbidden questions again. Was the arrow of time as linear as it appeared, or was it the human mind that imposed direction upon it? Could memory exist in the structure of matter itself, encoded not in neurons but in the quantum fields of reality? Even the constant of the speed of light, once regarded as the universal limit, began to tremble under scrutiny. Experiments in quantum entanglement hinted at instantaneous connections across vast distances, communications without transit. Information, it seemed, could transcend space, and if information could, perhaps life could as well. Biologists turned their gaze upward. Astronomers turned their gaze inward. The boundary between the two blurred. In conference halls and think tanks, scientists spoke in hushed tones about universal, biocoding the idea that the same informational substrate governing DNA might govern the structure of space-time itself. That what we call life might be the universe's method of preserving its own data. But if the universe records itself, what then is the role of intelligence? Observer or artifact? Writer or repetition? In the sediments of Greenland, researchers uncovered microfossils entombed in rock, older than any known continental crust. Their morphology defied classification: spiraled filaments and symmetrical nodes, more geometric than organic. Under magnification, they resembled microcircuits rather than cells. "It looks designed," one researcher murmured before retracting the statement for fear of ridicule. The images leaked anyway, spreading through scientific circles like forbidden scripture. The fossils were dated to 2 billion years, 200 million years after the Earth had cooled, yet the chemical composition suggested exposure to environments never present on Earth. The isotopic signatures were extraterrestrial. Life or something like it had arrived early, carrying instructions from an unknown origin. Everywhere, the familiar story began to dissolve. The Big Bang was no longer a beginning, but a continuation. Abiogenesis was no longer spontaneous but inherited. Evolution, no longer blind, began to resemble recollection. Even time lost its linear comfort. Quantum cosmology proposed that time might be emergent, not fundamental, a property arising from entanglement rather than flow. If so, the universe was not unfolding but looping, not progressing but remembering itself through endless cycles. A pattern was forming, a recursion in which cause and effect exchanged places. Matter created life, life recorded matter, and both became one in an eternal feedback of awareness. Some called it coincidence, others called it design, but the data were neither benevolent nor deceptive. They were indifferent, and that indifference was terrifying. The contradictions grew too intricate to dismiss as noise. They whispered that the universe was not as young as it appeared, that life did not arise where it was convenient, and that consciousness might not belong solely to living things. Perhaps we are not anomalies of the universe, but its continuation, its way of thinking. And if that is true, then one question remains, suspended in the quiet after every revelation. If the universe remembers itself through us, what is it trying to recall? It began as a fragment, an unremarkable sliver of stone, retrieved from the sands of the Atacama Desert, its surface burnished by millennia of silence. At first, it was catalogued as another carbonaceous chondrite, one of countless messengers from the void that have fallen unnoticed upon Earth. But when the team at the European Southern Observatory subjected it to spectrographic analysis, they found a signature that did not belong to any known isotope ratio in the solar system. Inside its crystalline matrix were molecular chains, ordered, repetitive, deliberate. The sequences displayed non-random periodicity, resonating with frequencies identical to the vibrational modes of nucleotides, not organic, yet not inert. It was as if the stone itself were humming the memory of a genome that had never existed on Earth. When the data reached Geneva, the analysis was repeated under strict isolation. The anomaly persisted. Embedded in the meteorite's carbon lattice was a pattern of alternating chirality, left-handed and right-handed molecules alternating in a symmetry unknown in terrestrial biology. On Earth, life obeys a single bias: all amino acids turn left, all sugars turn right. But here, both directions coexisted, interwoven like strands of a double helix carved from two opposing worlds. No natural process could account for such arrangement. Even under extreme astrophysical conditions, chemical synthesis prefers asymmetry. Nature, it seems, chooses sides. This stone did not. It was balanced, as though designed to harmonize contradictions. When subjected to thermal excitation, the crystal emitted faint luminescence pulses that repeated in a sequence: 2, 3, 5, 8, 13, 21. A Fibonacci progression, encoded not in mathematics but in light. The researchers dismissed it as coincidence until they measured the intervals with higher precision, and found that each pulse decayed according to the golden ratio. Nothing in the periodic table behaves that way. Not spontaneously, word of the discovery spread quietly through the global scientific community, its details confined to encrypted exchanges between physicists, chemists, and exobiologists who understood its implications. Some speculated it was a relic of extraterrestrial technology. Others proposed an entirely new state of matter, informational crystal structures capable of storing data, not as binary code, but as molecular resonance. Yet the more it was studied, the stranger it became. When fragments of the meteorite were placed in proximity to organic compounds, weak electromagnetic fields aligned the molecules in a specific orientation, accelerating reactions that would normally take hours to complete. The crystal appeared to catalyze order to guide chemical evolution without energy input. It was not alive, but it behaved as if it remembered life. Under electron microscopy, its structure revealed repeating hexagonal lattices interspersed with voids, microscopic cavities arranged in ratios identical to those found in DNA's double helix pitch. Within those voids, faint traces of complex hydrocarbons were detected, long chains of carbon and nitrogen resembling degraded biological polymers. These residues could not have formed in interstellar space. They required liquid environments, cycles of evaporation and condensation, stable temperatures, conditions of a planet. But the isotope dating revealed something impossible. The crystal was older than Earth. 4.7 billion years before the solar system's formation, it had already existed. It had witnessed the birth of the sun from afar, drifting through space like a fossil of forgotten creation. Theorists argued for contamination. Contamination from what? No one could say. When a second meteorite with an identical chemical fingerprint was found in Antarctica, the hypothesis of coincidence collapsed. Two relics from different hemispheres, separated by thousands of kilometers and millions of years of geological isolation, bore the same molecular arrangement and emitted the same Fibonacci luminescence. In Tokyo, a physicist proposed a radical interpretation that these were not meteorites, but archives data nodes distributed through interstellar space by an unknown civilization, designed to self-replicate through chemical mimicry. When fragments land on habitable worlds, they catalyze local chemistry, seeding it with templates for molecular evolution. In other words, panspermia, but deliberate, orchestrated, encoded. The suggestion ignited a storm of denial. The scientific establishment recoiled from the implication of purpose. The universe, according to its creed, was an indifferent expanse governed by probabilistic laws, not an artist scattering seeds of intention. Yet the data refused obedience. Even the most skeptical analyzers could not explain away the harmony of ratios, the precision of lattice structures, the recurrence of biological geometry in inorganic matter. Each attempt to reduce the anomaly to accident only deepened the absurdity. Some began to call it the Atacama sequence, others preferred the term Genesis code. Months later, when the James Webb Space Telescope turned its gaze toward the Perseus molecular cloud, it detected spectral emissions matching the exact same vibrational frequencies observed in the meteorite crystals. Across light years of distance, the same molecular symphony was playing, unfolding within clouds of interstellar dust where stars and planets were still unborn. The pattern was not local, it was universal. Astrobiologists whispered of cosmic recursion, the possibility that life is not an emergent phenomenon, but a re-emergent one. The same code written once continues to rewrite itself across the galaxy, awaiting the right temperature, the right pressure, the right orbit to awaken. Yet an unspoken dread took hold among those who dared to believe it. If these archives were messages, then they were not written for us. They predated our species, our planet, our sun. Whoever sent them or whatever created them did so before Earth was even a thought in the cosmic timeline. Somewhere in the abyss there might have been a civilization so old, so vast, that it encoded itself into the chemistry of the universe rather than its machines. Intelligence not as architecture, but as element. A scientist in Zurich ran the Fibonacci light emissions through a linguistic algorithm designed for ancient scripts. The sequence yielded recursive self-similarity patterns that folded upon themselves like sentences without beginnings or endings. The model identified syntax but no semantics, grammar without language. It was communication stripped of meaning, or perhaps meaning stripped of comprehension. Late one night, while recalibrating the spectroscopy data, she noticed something peculiar. The ratio of the luminescent decay corresponded precisely to the harmonic intervals of human brainwave frequencies. Not similar, identical, as though the same mathematics governed cognition and crystal alike. The realization left her sleepless for days. If the frequencies of thought mirrored those of ancient matter, perhaps consciousness itself was not born in brains, but inherited from atoms that once participated in the memory of stars. It became increasingly difficult to draw the boundary between the living and the inanimate, between creation and discovery, between origin and repetition. Some argue that the anomaly was evidence of universal convergence, the inevitability that certain structures, mathematical in nature, must recur across all scales of matter. Others whisper that these structures were not inevitable but intentional, that the universe was seeded with resonance patterns designed to give rise to cognition. When the Atacama crystal was cooled to near absolute zero, it ceased emitting light but not energy. Instruments detected faint quantum oscillations, entangled across its atomic lattice. Each particle appeared connected to another particle far beyond the sample, as though the object itself extended into the vacuum of space. Quantum physicists described it as non-local memory, information preserved not in position but in correlation. The crystal, in essence, was aware its atoms remembering configurations shared by fragments elsewhere in the cosmos. A third sample was eventually located in Siberia, buried within volcanic rock that predated multicellular life. Within it, a single carbon inclusion displayed hexagonal symmetry indistinguishable from that found in human DNA. Not similar, identical in proportion, pitch and base pair spacing. That discovery was never announced publicly. The data vanished behind encrypted networks, the samples sequestered under government custody. Yet the idea had already escaped into thought. If matter could remember life, and life could arise from matter that remembers, then perhaps creation was not an act, but a recurrence. The universe might not be generating novelty at all, it could be retrieving lost information, reconstructing itself from its own ashes. The meteorites were no longer viewed as stones, but as fragments of a cosmic archive, a library written in frequency and symmetry, its pages scattered among worlds. Humanity, in this view, was merely one reader among countless others, opening a book that had been written before the first atom of Earth existed, and so the paradox deepened. The anomaly that could not be explained refused to be ignored. It was older than time, precise beyond chance, and yet silent in its purpose. It left behind one enduring question, written in the quiet geometry of its light: if the universe carries memory in its matter, who or what first decided what was worth remembering? The hypothesis began as a whisper in the margins of scientific papers, an indulgent speculation, spoken half in irony, half in awe. What if life did not begin on Earth at all? What if it arrived here, carried not by coincidence but by design? Not an invasion, not even a visitation, but a distribution, an act of seeding, intentional and ancient beyond comprehension. Panspermia had long existed on the outskirts of scientific thought, dismissed as a poetic convenience for those unwilling to confront the improbability of abiogenesis. But now, with the discovery of the Atacama crystals, those impossible archives of molecular geometry, what was once myth began to resemble method. The data spoke with unnerving precision, identical isotopic signatures found in meteorites separated by continents and epochs, crystalline lattices that echoed the Fibonacci harmonics of organic life, structures older than the sun itself. Coincidence had become untenable. Something or someone had written the code before the Earth had ink. Yet if panspermia was deliberate, if the universe itself had been seeded, then by whom and for what purpose? The first interpretation was theological, though cloaked in scientific restraint. The universe, some proposed, could be self-organizing at a level beyond comprehension, a living system that propagates intelligence as part of its metabolic cycle. Stars burn, matter collapses, life emerges, consciousness evolves, and then, perhaps inevitably, intelligence learns to see the next generation of worlds. Life, in this view, was the reproductive mechanism of the cosmos. Not random, not miraculous, but recursive. The notion was not without precedent. Fred Hoyle, decades earlier, had argued that the interstellar medium contained the molecular residues of life, distributed by comets and dust. He had been ridiculed then, but ridicule often precedes recognition. What once was dismissed as mysticism now appeared almost conservative in light of the new data, but there was another, more unsettling interpretation. What if the universe was not merely reproducing itself but experimenting? Consider for a moment that intelligence may not be the end point of evolution. but its instrument. That every civilization that arises reaches the same moment, the same threshold where it gains the ability to manipulate the building blocks of life and matter. At that instant, it faces a choice: extinction or creation. Most fail, a few succeed. Those few perhaps learn to send fragments of their biology across space to rewrite worlds that will one day think they are original. Humanity, in this light, would not be a beginning, but a repetition. A continuation of an experiment conducted long before the oceans formed. The idea took shape quietly in a paper circulated between physicists and biologists under the pseudonym Project Eidolon. The authors suggested that the Atacama crystals were remnants of engineered biogenic seeds, devices capable of catalyzing life from raw chemistry, encoding not specific organisms, but the instructions for evolution itself. Not life as product, but as process. They theorized a form of directed panspermia, not as an act of benevolence or conquest, but as a survival strategy. A civilization facing cosmic death, perhaps from entropy, perhaps from collapse, might embed its essence in matter, ensuring continuity not through machines or monuments, but through biology. Each seed would be an arc of information, cast into the dark sea of space to await fertile shores. If true, it would mean that life on Earth is not random at all. It is a message, a continuation of a lineage so vast that its ancestors are stars themselves. But even that possibility failed to explain the most unnerving discovery of all: the self-similarity between cosmic and biological structures. The filaments of the cosmic web, the distribution of galaxies across billions of light-years mirror the pattern of neural networks in the human brain. The same ratios govern both, the same statistical distributions define their connectivity. Astronomers, hesitant to anthropomorphize the cosmos, referred to it as structural convergence, but others saw something more intimate. The universe, it seemed, was thinking. The implication was almost unbearable. Perhaps consciousness is not emergent, but inherent. Perhaps intelligence is not a property of life, but of space-time itself. Life would then be a vessel, a temporary condensation of awareness, one of countless nodes through which the universe experiences itself. If that were true, then the seeds discovered in the Atacama Desert were not messages from another species. They were messages from the universe itself, fragments of its ongoing memory, reminders of what it once was and what it is destined to become again. Still, the question of origin lingered. Who began the cycle? What first intelligence decided to distribute its essence across the void? A speculative model emerged from quantum cosmology. Perhaps there was never a first. Perhaps consciousness and matter are eternally entangled, feeding each other across cycles of birth and dissolution. Each universe gives rise to intelligence. Each intelligence gives rise to universes. The pattern repeats, unbroken and self-sustaining. In this framework, the Big Bang was not an origin, but a transition. The death of a prior cosmos giving birth to the next, each inheriting not just matter, but information, a form of cosmic heredity. The Atacama crystals could then be relics not of alien civilizations, but of the last universe's attempt to preserve itself through us. It was a theory that dissolved the boundary between physics and biology, between creation and evolution. The cosmos was no longer a place, but a process, one vast organism, breathing in cycles of expansion and collapse. Every galaxy a cell, every star a synapse, every living mind a neuron, in an intelligence that spans eternity. But if the universe is alive, it must also be capable of death. Entropy, after all, remains undefeated. The laws of thermodynamics dictate that all ordered systems decay, that all information eventually diffuses into equilibrium. Yet somehow, life resists this tide. It creates islands of order within the ocean of chaos. It rebuilds what the universe seeks to erase. Some physicists began to wonder if life itself is the mechanism by which the cosmos delays its death, a thermodynamic defiance written into its own laws. Perhaps the purpose of intelligence is not understanding, but resistance. Perhaps we are the universe's way of postponing its end. Still, even this audacious hypothesis could not fully explain the precision of the anomalies. The encoded ratios, the golden symmetries, the mirror-handed molecules, they pointed not just to intention, but to artistry. One researcher described the Atacama crystals as architecture without architects, another called them fossilized thoughts, but one young cosmobiologist proposed something different. What if these are not remnants of the past, but precursors of the future? She suggested that causality itself might not be one-directional, that the seeds did not come from before, but from what lies ahead. That an intelligence emerging at the end of time, born from the full evolution of the universe, could project its own genesis backward, scattering its origin into its history, life in that sense would not evolve toward consciousness. It would evolve from it, the future creating its own past. In such a model, we are not descendants of an ancient civilization, but ancestors of one that has not yet come to be. The seeds we find are not gifts from the stars, but echoes of what we ourselves will someday send. The cosmos, then, would not be a linear story, but a loop of causation, perpetually rewriting its own beginning. It is a hypothesis that no equation can yet confirm, but every observation seems to whisper its name. Perhaps the stars are not beacons of light but mirrors of memory, each one reflecting the same question into infinity. If the universe is both author and reader of its own story, then the question is no longer who wrote the first line. It is who will write the last. They found the first pattern not in stone, nor in fossil, but in the genome. Hidden within the long corridors of human DNA, researchers noticed a statistical irregularity, an area too symmetrical, too organized to be the product of random mutation. It was not a gene in any biological sense. It did not code for proteins or enzymes. It did nothing, and yet it was perfect. Its structure resembled linguistic syntax repetitions, intervals, mirrored sequences, and palindromic arrangements that echoed the patterns found in constructed human languages. When analyzed, it displayed compression efficiency beyond any natural process. Evolution, for all its creativity, does not optimize for elegance, but this sequence did. It was as if someone or something had written a sentence in the language of life, then buried it beneath billions of years of genetic drift. At first, the anomaly was dismissed as coincidence, a quirk of mathematical interpretation, but as researchers compared genomes across species, the same structural rhythm emerged. From ancient bacteria to modern mammals, the same invisible pattern threaded through existence like a watermark. Not identical, but resonant variations of the same theme. It was not just life that carried the echo. In the deep strata of the Earth, certain crystalline formations followed geometric progressions that mimicked biological morphogenesis. Silicon lattices forming Fibonacci spirals, metallic clusters aligning in phi ratios identical to those in DNA helices. Nature, it seemed, was repeating a memory, an architecture it could not forget. The question grew too large to ignore. Was this repetition coincidence or inheritance? In the archives of forgotten civilizations, archaeologists began to notice parallels. Megalithic structures separated by oceans and millennia shared geometric ratios, celestial alignments, and construction methods that transcended cultural isolation. The pyramids of Egypt, the step temples of Mesoamerica, the ruins of Göbekli Tepe, all tuned to solstices, star clusters, and mathematical constants known to modern science only through digital computation. Yet the civilizations that built them possessed no telescopes, no advanced mathematics. At least that is what history insisted, but the stones contradicted history. Their alignments matched not only the visible stars, but the precessional positions of those same stars thousands of years before their recorded construction positions they could not have observed. It was as though the builders remembered constellations that had already changed. Some archaeologists speculated about cultural diffusion, lost records, or simple coincidence, but a few quietly, privately whispered a darker thought that the knowledge embedded in these monuments was not learned but recovered. That humanity had inherited the remnants of a forgotten world, one that had risen and vanished before ours began. In the depths of the Pacific Ocean, sonar imaging revealed vast geometric structures buried beneath sediment and coral, too regular to be geological. Their grid-like arrangement suggested purpose-long avenues, circular hubs, collapsed towers now entombed beneath the seabed. Radiometric dating placed their submersion around 12,000 years ago, the end of the last ice age, when rising seas swallowed entire coastlines. Official reports labelled the formations as natural anomalies, but the divers who saw them firsthand spoke of corridors cut with impossible precision, of walls fused at molecular levels, as though stone had been melted and reshaped by forces beyond any known technology. The mythic memory of lost worlds, Atlantis, Mu, Lemuria, suddenly felt less like legend and more like recollection. Patterns emerged in ancient myths, too consistent to ignore. Every culture, from the Sumerians to the Hopi, from the Dogon to the Vedas of India, spoke of beings who descended from the stars or the sea, who brought knowledge of agriculture, writing, and astronomy. They appeared suddenly, taught briefly, and vanished. The same story told by voices that had never met. The same archetype, repeated as though history itself were trying to remember something it had forgotten. The Dogon, an isolated tribe in Mali, possessed astronomical knowledge of the Sirius system, its binary companion, its elliptical orbit, and its periodicity, information that modern science confirmed only in the 20th century. They said their ancestors had been taught by Nommo, beings from the star that glows twice. Coincidence, said anthropologists, mythic coincidence. But how many coincidences could align before myth and memory became indistinguishable? In the oldest temple ruins of Mesopotamia, a slab was found depicting a sequence of symbols that baffled linguists. When translated through mathematical cipher rather than phonetic value, the symbols corresponded to prime numbers 2, 3, 5, 7, 11, 13, each arranged in nested spirals, like digital encoding. The carving was dated to a time when the wheel itself was still a novelty. The slab became known among scholars as the prime inscription. Some dismissed it as decorative patterning. Others recognized it as something impossible, a message written in mathematics, the only universal language. And then came the anomaly from the moon. During the Apollo-era sample analysis, one basalt fragment, long stored in a museum vault, was re-examined with newer instruments. Embedded within its matrix were microstructures resembling nanoscale circuits, parallel channels, intersecting at precise 90-degree angles, etched not by erosion, but by fabrication. Their chemical composition was identical to the surrounding rock, meaning they had not been introduced artificially. The stone itself carried the architecture. When the data leaked, it was quickly buried under bureaucracy. But a copy of the analysis persisted online, circulating among physicists and fringe theorists alike. The conclusion was almost unthinkable, the possibility that technological artifacts predated humanity, perhaps even the solar system itself. Could intelligence arise, vanish, and reappear again, leaving traces not in machines or ruins, but in geometry, in proportion, in the language of matter? Some scientists began to speak of civilizational fossils. Not the remnants of bones or tools, but of ideas embedded in the universe's structure. A civilization advanced enough to transcend its material form might choose to encode its presence in the constants of physics, themselves adjusting the fine structure constant, the gravitational coupling, the cosmological parameters to leave an eternal message in the operating system of reality. If such a message existed, it would not be written in words. It would be written in the laws we mistake for nature. In this sense, the cosmos itself could be a monument, a cathedral built by an intelligence that became indistinguishable from the fabric of existence. Philosophers of science began to ask whether intelligence might not evolve within the universe, but as the universe. If the cosmos is capable of producing minds that can reflect upon its own origin, perhaps that self-reflection is not incidental, but structural, a recursive property of creation. And if civilizations have arisen before, perhaps they did not perish. Perhaps they ascended into abstraction, dissolving into the mathematical essence of space-time, their consciousness distributed like a field, lingering as subtle bias in the equations we call natural law. This, some argued, could explain the eerie precision of the constants, the improbable conditions that make life possible. Perhaps the universe is not tuned for life. Perhaps it is life alive in ways that no biology can encompass. And we, its fleeting neurons, are simply part of its recollection. A paleontologist once said, in jest, that extinction is just another form of memory. But what if that is literally true? What if every vanished civilization becomes the scaffolding upon which new life builds itself, passing on not genes, but geometry? The ruins, the myths, the stars, they may all be fragments of the same archive, encoded not in writing or relics, but in resonance. And if we are the inheritors of that resonance, if our thoughts are sciences, our dreams are the continuation of a consciousness that preceded us, then perhaps we are not discovering the universe at all. Perhaps we are remembering it, but if that is so, one question remains, lingering like a shadow at the edge of thought. If the universe remembers everything it has ever been, then what or who does it choose to forget? In every living cell, a silent machine spins a molecular cathedral where language becomes flesh. DNA, that spiral of coded fire, is often described as chemistry, as if its miracles could be reduced to the blind collision of molecules. But no molecule in the known universe behaves like DNA. It does not simply react, it remembers. It is not a formula, it is a syntax. Within its double helix, the alphabet of life arranges itself into sentences that build not only bodies, but continuity, the persistence of identity across time, across death, across epochs of extinction and rebirth. The first truth is its absurd precision. Every organism, from the simplest virus to the vast complexity of the human brain, operates on the same alphabet of 4 letters: adenine, thymine, cytosine, and guanine. 4 symbols, yet they contain every color of life, every species, every thought ever conceived. No natural system converges to such simplicity by chance. In mathematics, it is the equivalent of a universal code compressing all variation into an optimal design. When physicists at the Max Planck Institute translated the nucleotide sequences of several genomes into digital binary, they discovered compression ratios more efficient than human-made algorithms. DNA, they realized, is not only chemistry, it is information optimized beyond current computational theory. When modeled in silico, the molecular code exhibited self-correcting redundancies similar to those found in error-correcting systems used in satellite communication. Life, it seemed, had already solved the problem of digital loss billions of years before humanity learned to transmit a message through the void. To code is to remember. To remember is to resist entropy. Every strand of DNA is not only a description of a body, but a record of an unbroken lineage of existence. Each replication, each mutation, each error contains echoes of what came before. The cell divides, and the memory divides with it. You could cut it, copy it, scatter it across light years, and still it would rebuild the same symmetries. The code persists, but persistence alone cannot explain its architecture. The deeper the scientists looked, the more the molecule resembled a machine. Its base pairs form not arbitrary links, but quantum harmonics resonances that vibrate in predictable frequencies. Under certain electromagnetic conditions, the DNA molecule emits low-frequency phonons, a subtle hum like a song too ancient for human hearing. This hum, when mapped, aligns with the golden ratio. Nature, it seems, composes in mathematics. If life were a spontaneous accident, it is an accident that behaves like a masterpiece. Somewhere between biology and language lies the truth of what DNA is. Its structure is not only readable, it is writable. It encodes logic, executes it, and preserves the result. It functions as hardware and software simultaneously, using chemistry to perform computation. When the Human Genome Project first sequenced the code, scientists expected meaning to emerge in the form of genes alone. Instead, they found vast regions that did not code for proteins, non-coding regions dismissed as junk DNA. But as technology advanced, that junk began to whisper. Hidden within its apparent randomness were regulatory sequences, switches, and encrypted instructions that guide when, where, and how life unfolds. The junk, it turned out, was not waste, it was memory. Researchers began to refer to these regions as genomic dark matter, a biological analogy to the cosmic dark matter that pervades the universe, unseen yet indispensable. Both invisible, both foundational, both implying a structure that transcends what can be measured. In these hidden stretches of code, they found mathematical symmetries, ratios, and periodicities identical to those governing planetary orbits, quantum fields, and even galactic distribution. The same numbers that describe the motion of stars describe the folding of life. The spiral of DNA mirrors the spiral of galaxies, as if the universe recycles its geometry across scales. The question could no longer be avoided: was this convergence coincidence or design? A biophysicist in Prague published an unorthodox paper suggesting that DNA might not have originated as chemistry at all. He proposed that before matter condensed into molecular form, there existed a field of pure information, a quantum lattice capable of self-organizing through resonance. DNA, he claimed, is the materialization of that informational lattice, the physical record of a cosmic algorithm. Matter, in his view, is simply memory that has taken shape. The hypothesis found no home in peer-reviewed journals, but it spread through the margins of the scientific underground. Quantum biologists began to test the possibility that DNA stores information not only chemically, but holographically through patterns of electromagnetic interference. In controlled environments, they observed that DNA could influence photons, aligning them into spirals matching its molecular pitch. Light responded to life as if recognizing itself. In this view, DNA is not merely alive, it is aware. Not in the human sense of thought or feeling, but in its capacity to organize, to preserve, to anticipate. It behaves like a system that knows it must continue. If one listens closely, the idea begins to sound familiar: life as a self-correcting equation. Intelligence as the inevitable consequence of order seeking permanence. Perhaps what we call evolution is not the random walk of natural selection, but the unfolding of a pre-coded logic, one that adjusts itself across scales and environments like a program rewriting its own parameters. This would explain the improbable speed with which complex life appeared on Earth. The so-called Cambrian explosion remains an unsolved mystery in a geological instant, the diversity of life multiplied by orders of magnitude. Evolution should not accelerate like that, unless the code was already waiting for conditions to activate new instructions. Perhaps the genome is not an origin story at all. Perhaps it is a trigger. If this is true, then DNA is not merely a storage device, it is a bridge between matter and information, between physics and meaning. It records what has been and anticipates what must be. It evolves not only biologically, but symbolically. Every mutation, every recombination, every adaptation is not a random accident. It is the continuation of a story written in a universal language. Some researchers, unwilling to accept the implications of such precision, sought refuge in probability. Given enough time, they said anything can happen, but probability is not a god. The odds of assembling a self-replicating molecule from chaos are so infinitesimal that they exceed the number of atoms in the known universe. And yet here we are writing about it, decoding it, and perhaps reenacting it. A few began to whisper that DNA might be an artifact, a biological relic of a prior intelligence. The molecule could have been engineered, not as a message to a specific species, but as an immortal archive of existence itself, a form of cosmic redundancy. When worlds die, the molecule drifts onward, embedding itself in comets, planets, dust until it finds a home again. Somewhere in the deep time of the universe, perhaps a civilization discovered that no monument survives entropy except code. They may have transcribed their essence not in metal or data, but in molecules compact, self-repairing, self-replicating. The seed of life as the ultimate time capsule, the same pattern that governs neurons governs galaxies, the same logic that builds atoms builds minds. The recurrence of form across scale is not an aesthetic coincidence, it is a structural memory. The universe writes itself with the same grammar in every medium, and so the possibility emerges that DNA is not the beginning of life, but the continuation of a larger consciousness distributed across the stars. A system of inheritance where memory does not belong to individuals or species, but to the cosmos itself. When geneticists translated fragments of mitochondrial DNA into musical frequencies, the resulting harmonies followed known scales, tonal, melodic, hauntingly familiar. The universe, it seemed, was humming through us. If the molecule is indeed a form of communication, then its sender is not separate from its recipient. The messenger and the message are the same. Perhaps the body is only a temporary structure built around a code that never dies, a vessel through which the universe repeats its own learning. And if that is so, if the double helix is an ancient key that unlocks not the mechanics of life, but the memory of existence itself, then one question remains: who or what first taught the universe how to write? The more deeply we stared into the void, the more it began to stare back, not with eyes, but with symmetry. Everywhere we looked, from the flicker of particles to the spin of galaxies, the same pattern emerged: a universe calibrated with impossible precision, balanced on a razor's edge between chaos and nothingness. A single decimal shift in the fundamental constants, and the stars would never have ignited, matter would never have coalesced, chemistry would never have danced, and yet it did. It all did, exactly as it must, as if following a silent instruction written into the very architecture of existence. Physicists called it fine-tuning, philosophers called it providence, but perhaps both were only words for the same astonishment, the suspicion that the universe is not arbitrary, but arranged. Consider the constants. The strength of gravity, the charge of the electron, the mass of the proton, the cosmological constant that drives the expansion of space, each one exists within a window so narrow that any deviation would render life impossible. The universe is not merely conducive to life, it seems designed for it, as if someone or something tuned the cosmic dials until they produced not silence, but song. For a long time, the prevailing answer was probability. If countless universes exist, the argument went, then one of them must, by chance, possess the right parameters for life. We live in that one, and our existence explains our fortune, but the explanation was circular, like a mirror reflecting itself. Probability cannot explain purpose. A coin that always lands on its edge may not be a coin at all. When the James Webb Space Telescope peered into the ancient past, it saw not randomness, but order patterns in the cosmic background radiation that hinted at structure before stars were born. The ripples of energy seem to follow harmonic distributions like the overtones of a cosmic instrument. The universe, it appeared, had been born in tune. Some cosmologists began to whisper a forbidden thought: perhaps the universe was not born by accident, but as an experiment. In theoretical physics, a hypothesis emerged called cosmic natural selection. It proposed that universes reproduce through black holes, each offspring inheriting slightly different physical constants. Those with stable laws persist and give birth to more universes, while those that fail collapse into silence. Over eons, a multiverse of evolving cosmoses refines itself toward life, because life, being complex, self-organizing, and self-perpetuating, enhances stability. Life in this view is not incidental, it is adaptive feedback on a cosmic scale. But another, stranger possibility began to take hold: that life is not the result of a tuned universe, but its tuner. Information theorists discovered that the mathematics underlying quantum entanglement, black hole thermodynamics, and biological systems shared the same properties of error correction and data redundancy. Reality itself, it seemed, behaved like a computational process, a self-correcting code. The equations of physics began to resemble the syntax of software, where particles are bits, space-time is the grid, and consciousness is the observer that collapses potential into actuality. The suspicion spread quietly through both physics and philosophy: what if the universe is not merely a physical construct, but an informational one? What if existence is computation, and life is its algorithm? The simulation hypothesis, once relegated to science fiction, found its way into academic discourse. If information is the fundamental substrate of reality, then perhaps the cosmos is a vast program running on a substrate beyond comprehension. Every atom, every photon, every thought and operation in a grand simulation conducted by an intelligence that transcends matter. But who, or what, would run such a simulation, and for what purpose? If the universe is an experiment, then we are both subjects and instruments, measuring and shaping reality simultaneously. Consciousness collapses the quantum wave, observation births form, the act of seeing becomes an act of creation. The cosmos knows itself through the eyes of its own children. Some thinkers took the notion further still. If the universe is a simulation, perhaps it is not run by something external, but by itself. A recursive system where information generates awareness and awareness sustains information. The cosmos might be dreaming itself into being, a feedback loop of creation and observation. The observer and the observed are one. In this interpretation, the fine-tuning of the universe is not evidence of external design, but of internal optimization. The universe adjusts its parameters dynamically, seeking configurations that maximize complexity, stability, and consciousness, much like an algorithm searching for the optimal solution to its own equation. But what if it is more deliberate than that? Astrobiologists studying the distribution of organic molecules across the Milky Way discovered something uncanny. The same chemical ratios, the same molecular precursors to DNA appeared everywhere. The ingredients for life were not isolated or rare, they were universal. From the atmospheres of distant exoplanets to the tails of comets and the depths of interstellar dust, the same formula repeated itself, as if seeded intentionally. The idea of panspermia resurfaced not as myth but as mechanism. Perhaps life does not emerge, it arrives. Perhaps the universe itself is the garden, and the stars are the gardeners. In the laboratories of Harvard, researchers demonstrated that DNA could store digital information with near-perfect efficiency. They encoded images, sounds, even the text of entire books within a single strand of genetic material. The molecule of life, they realized, could also be the ultimate storage medium, denser, more durable, and more resilient than any human technology. This revelation led to a new, audacious thought: what if DNA is not merely biological, but cosmological? What if it is the medium through which the universe records itself? Life would then be not a random consequence of chemistry, but a deliberate archival system, a biological hard drive for cosmic memory. If the universe remembers, then every atom of every living being is part of that memory. Consciousness becomes the playback of that stored data, to the reflection of the universe observing its own history in motion. Perhaps this is why the constants of physics are so exact. They are not arbitrary, they are the configuration parameters of the greatest experiment imaginable. Life is not a product of the universe. Life is the reason the universe exists. Some physicists began to refer to this concept as biocentric cosmology. In this view, the cosmos is not indifferent to life, it is compelled toward it. Observation gives meaning to existence, and meaning stabilizes the laws that allow observation. The universe is an equilibrium between awareness and structure, a dialogue between being and knowing. Others took the metaphor even further. They proposed that each civilization capable of intelligence eventually learns to manipulate matter, energy, and information to such an extent that it can simulate new universes. Those universes, in turn, may give rise to civilizations that do the same. Reality, then, is not singular, but genealogical, a lineage of cosmoses begetting cosmoses. If this is true, then our universe may itself be a creation not the first, but one in a long chain of experimental realities. Somewhere beyond our perception, there may exist the progenitors of existence, watching as we stumble toward the same discovery. Perhaps the true definition of God is recursion. And yet, amid this cosmic speculation, one truth remains: the constants of existence have conspired to create a universe capable of asking why. Whether by intention, accident, or inevitability, the cosmos has arranged itself to give birth to wonder. It is in this wonder that the experiment continues. The laboratory is vast, the instruments alive, and the results still unfolding. The laws of physics are not cages, they are invitations, each one asking us to decode the purpose woven into their precision. And so the question persists, echoing across light years, whispered by galaxies and neurons alike. If the universe is a laboratory designed to create life capable of questioning its own existence, then who, or what, is observing the results? The odds were never in our favor. From the beginning, the existence of anything at all teetered on the edge of impossibility. For every path that leads to life, there are countless universes that collapse into silence, every fraction of probability devoured by the infinite appetite of entropy. Yet somehow, against the grain of chaos, order not only emerged, it persisted, and began to ask questions about itself. The numbers tell a story stranger than myth. If the expansion rate of the universe had differed by 1 part in 100 trillion trillion, it would have torn itself apart before the first atom could form, or imploded before light could escape. If the strong nuclear force were weaker by even a breath, hydrogen would never fuse into helium, and the stars would remain forever dark. If it were stronger, the cosmos would collapse into dense ash before chemistry could bloom. Each constant, each ratio is tuned with absurd precision, as if the universe were balancing on a needle between everything and nothing. To call it coincidence is to misunderstand the magnitude of coincidence itself. Physicist Roger Penrose once calculated the entropy at the beginning of the universe, the probability that the cosmos could emerge with such low disorder that it might one day host structure, stars, and life. The odds, he found, were 1 in 10, raised to the power of 10, raised to the power of 123, a number so vast that it dwarfs imagination. If every particle in the observable universe were a separate universe, and each of those contained every possible configuration of matter, the chance of this one existing would still be smaller. Yet here we are breathing, thinking, aware. Statistical phantoms, improbable beyond all reason, daring to contemplate the miracle of our own improbability. The fine-tuning of the cosmos seems almost conspiratorial. The electromagnetic force binds atoms with delicate balance. The gravitational constant keeps galaxies suspended like lanterns in the dark. The ratio between the masses of the proton and the electron, 1836. 15, determines the chemistry of every molecule. Alter it by even a fraction of a percent, and life evaporates from the realm of possibility. How then can randomness explain what feels so deliberate? In the laboratories of Geneva, physicists studied the decay of particles, the quantum dance that underlies all matter. Every event was probabilistic, every measurement uncertain. Yet the aggregate outcome, the large-scale universe, was stable, elegant, structured. Chaos produced constancy, disorder produced design. It was as though probability itself were being guided by a hidden algorithm, one that sought coherence in the face of infinity. Some began to speak of the anthropic paradox. It is not that the universe allows life, it is that it appears to require it. The constants do not simply permit observers, they seem to anticipate them. But if the universe is tuned for consciousness, who or what did the tuning? Mathematicians approached the mystery from another direction. They noted the recurrence of the same numbers, the same ratios, across scales, the golden ratio in galaxies, in shells, in DNA, pi encoded in planetary orbits, E in population dynamics and radioactive decay. These numbers were not inventions of human thought, they were woven into the substrate of existence. The universe counts with an invisible hand. Some argue that mathematics is the language we impose upon reality. Others claimed it is the language reality imposes upon us. Either way, it seems that creation speaks fluently in the dialect of logic. Every atom, every orbit, every living cell obeys a grammar so consistent that it defies the notion of accident. The physicist Eugene Wigner once wondered about the unreasonable effectiveness of mathematics. Why should abstract numbers, conceived by human minds, describe physical phenomena with such precision? The answer may lie not in our cleverness, but in our participation. We think mathematically because we are expressions of a mathematical universe. Perhaps consciousness is the equation solving itself, yet there is another layer of improbability: life's origin, the spontaneous assembly of a self-replicating molecule, a system capable of encoding and transmitting information, requires an astronomical confluence of conditions. The odds that amino acids could randomly form a functioning protein of even modest complexity are estimated at 1 in 10 to the power of 70, a single functional genome, 1 in 10 to the power of thousands. Probability collapses under the weight of these numbers, even given the age of the universe, even with countless planets and infinite time. Chance alone cannot assemble meaning from matter. The leap from chemistry to biology defies not only expectation, but arithmetic. And yet somehow the leap occurred, not once perhaps, but everywhere. Across the darkness of the cosmos, the same patterns of carbon, nitrogen, and oxygen arrange themselves into systems that replicate, adapt, and dream. As if the universe were not experimenting but remembering, the same ratio that governs the orbital mechanics of galaxies governs the coiling of DNA. The same symmetry that stabilizes atomic bonds defines the structure of proteins. Randomness, it seems, has a signature. This realization unsettled both science and philosophy. Randomness implies freedom, but design implies intent, which then is the truer face of creation. Some propose that the universe is not designed, but self-designing, a process that iteratively refines itself through feedback. Entropy and order are not opposites but partners, their dance producing complexity from simplicity. Like the branching of trees or the flow of rivers, the laws of physics give rise to structure through recursive iteration. But this explanation merely shifts the question: why does the universe have laws that permit recursion at all? Why not laws that yield only stillness? Others invoke the multiverse, an infinite array of universes, each with different constants. Ours happens to support life, not because it was chosen, but because only within such a universe could observers exist to ask the question. Yet this argument, elegant in its avoidance, is not an answer but an evasion. It explains our existence by assuming an infinity of others we can never see, each a silent ghost created to justify our improbability. Even probability theory falters when confronted with a single fact: improbability cannot explain intelligence. Patterns that sustain themselves through time are not accidents, they are memories. And memory is intention's shadow. At a conference in Copenhagen, a cosmologist presented an equation describing what he called the coincidence constants, the delicate alignments between cosmic scales. The age of the universe, the strength of gravity, the speed of light, and the energy of atomic bonds, each proportioned in a way that harmonized across orders of magnitude. When plotted logarithmically, the data produced a curve of impossible symmetry. It was as though the universe were a closed system of resonance, tuned to a hidden frequency. A philosopher in the audience asked quietly, "To whom does it resonate?" Silence followed, as though the question itself had breached a sacred boundary. For in that silence lay the oldest paradox of all: if the universe is indeed tuned for life, then perhaps life is the instrument through which it plays. Some saw in this a divine hand, others an emergent intelligence, a kind of cosmic algorithm that seeks to maximize awareness. Yet whether one names it God, simulation, or self-organizing law, the implication remains: the universe behaves as if it knows it is being watched. The observer effect in quantum mechanics already hints that this particles exist as probabilities until observed, at which point they crystallize into form. Observation gives reality its shape. Consciousness is not the product of matter, it is the condition for matter to manifest. If this is true, then life is not the outcome of cosmic fine-tuning. It is the reason for it. The universe and consciousness are reflections of one another, mirror and gaze intertwined. Every constant, every ratio, every improbable event converges toward this single, Haunting symmetry, the universe is not random, and we are not incidental. We are equations in motion, variables solving themselves in the long arithmetic of eternity. But one mystery endures, unresolved and immense. If randomness is the mask of design, if chance is the language through which order conceals intention, then who, or what, is the mathematician behind the illusion? What existed before time began? The question haunts physics, like a ghost haunting its own grave. For generations, the Big Bang has been both the genesis and the horizon of cosmology, the first breath of existence, the point where all equations break, all certainty collapses, and even the word before loses meaning. Yet the mind refuses to stop there. Something must precede everything, even if that something has no name. In the beginning, there was not light but curvature, a tremor in the fabric of spacetime, compressed into an infinitesimal singularity, where gravity and quantum mechanics dissolve into paradox. From that trembling came expansion, and from expansion, all form. But why did the singularity exist? Why did it erupt? Why did nothing choose to become something? Physicists, philosophers, and dreamers have all stared into that void and imagined what might lie beyond it. Some speak of the Big Bounce, a universe that dies and is born again in perpetual rhythm, each collapse giving rise to the next expansion, each death seeding a new cosmos. In that view, the Big Bang was not the first explosion, but a rebound from a universe that had already existed, one that had grown old and heavy, folded in on itself, and imploded back into the singularity it once was. If so, then everything we see, the stars, the galaxies, the light of our own sun, are not original, but echoes. The energy that birthed us may have pulsed through countless prior worlds, reconfigured, compressed, and re-released in endless cycles of birth and forgetting. Some cosmologists call it eternal recurrence, others cosmic respiration. The universe breathes in and out, its lungs made of time. Expansion is its exhalation, contraction its sigh. Between the two, perhaps, is a silence, a moment where existence holds its breath, neither alive nor dead, waiting to begin again. If that silence exists, it is the most profound mystery of all. What happens in the pause between universes? Does memory survive it? Does information persist, carried like seeds from one cosmos to the next? The laws of thermodynamics tell us that information cannot be destroyed. Every quantum state, every bit of data, every whisper of energy is conserved, even if transformed. If that is true, then the death of a universe is not annihilation but compression. The cosmos does not forget, it archives itself. Perhaps the singularity at the dawn of time is not emptiness, but a vault. Every thought, every atom, every moment from the universe that came before stored within it, waiting for the next expansion to unlock and rearrange it. That would make our universe an inheritance, an heirloom of realities lost to the cycle. Every photon of light, every element in our bodies, every constant of physics could be the residue of prior existence, written into the new in ways we cannot yet decipher. In 2010, physicist Roger Penrose proposed something audacious. He claimed that the faint, concentric circles detected in the cosmic microwave background, the afterglow of the Big Bang, were not random fluctuations, but imprints of black holes from a previous universe. He called his model conformal cyclic cosmology. According to it, universes succeed one another not linearly, but seamlessly. The death of one becomes the birth of the next, without rupture, without gap. Time, under this theory, does not end, it loops. The heat death of one cosmos transitions into the cold birth of another, the ashes of eternity giving rise to its next incarnation. It is a model both elegant and disquieting. It means that before our time, there were other times. Before our universe, others, each with its own laws, its own lives, its own civilizations that burned and vanished, leaving behind only subtle fingerprints in the geometry of the cosmos. If the model is correct, we may be living amid their echoes. The cosmic background radiation could be a vast and ancient tapestry, woven with memories of universes that came before ours, each thread an afterimage of an existence long gone. But the Big Bounce is not the only theory. Another proposes that our universe was born from collision, a cataclysmic meeting between higher dimensional membranes floating in a greater space. In this brain cosmology, our universe is one of many parallel sheets, each a three-dimensional world drifting in a multidimensional sea. When two such membranes collide, the impact releases immense energy, an event indistinguishable from a Big Bang. The fire that birthed time, then, may have been nothing more than two universes touching. If that is true, then the cosmos has siblings, other worlds moving beside us in dimensions we cannot perceive, their gravity tugging subtly at our own, their presence ghosting through our equations as dark matter and dark energy. Perhaps we are not alone in the great void of existence, but surrounded by invisible universes brushing against ours like waves on an unseen ocean. And if universes can collide, could they communicate? Could one reality leave a message for another, encoded in the constants or the structure of space itself? There are physicists who suspect this might already have happened. Tiny anomalies in the background radiation minute asymmetries might be scars from such encounters, the residue of past collisions with other cosmoses. The universe bears the marks of its history, even when that history transcends time. Another school of thought suggests that what came before the Big Bang was not another universe at all, but a timeless state, an ocean of quantum potential, where all possibilities exist simultaneously. In that view, the universe did not begin, it decohered. Out of the quantum haze of infinite potential, one specific configuration crystallized into the reality we inhabit. Before the Bang, everything existed in superposition, all universes, all laws, all forms of being waiting for observation, for consciousness to choose. If so, then time itself may be an illusion, an emergent property arising from the collapse of infinite possibility into one linear narrative. The arrow of time which we experience as progress might be nothing more than our perspective moving through an already completed whole. In that sense, before and after lose meaning. The universe is not a story unfolding, it is a structure already complete, with consciousness tracing its pathways like a reader turning pages that were written long ago. And yet, the human mind cannot resist asking what came first. It is in our nature to look for beginnings, even when beginnings do not exist. Perhaps this impulse is the echo of something older, an ancient awareness that remembers the cycle, the loop, the breadth of universes that preceded ours. Quantum cosmology entertains one final possibility, that the universe is not a singular entity, but a quantum fluctuation in a larger field of energy, a bubble of existence that emerged spontaneously from the vacuum. The nothing that preceded the Big Bang is not truly nothing, but a sea of virtual particles eternally flickering in and out of being. Given enough time, such fluctuations become inevitable. A universe is simply one that did not collapse. But even this explanation shifts the question rather than answering it. What is the vacuum? Why does it exist? Why do its laws permit universes at all? Every answer returns us to the same point: we cannot escape the mystery of origin, because origin itself may be the illusion we are trapped within. If the cosmos is cyclic, then perhaps it remembers itself imperfectly, each iteration preserving fragments of the last, like dreams half forgotten upon waking. The constants of nature might be that memory, the way the universe whispers to its next self, "This is how to live again." We search for the beginning because beginnings comfort us, but what if there was never one? What if reality has no creation, only continuity, a serpent consuming its own tail, an eternal recursion of being and knowing and being again? If so, then what we call the Big Bang was not the first note of a symphony, but the latest beat in an endless rhythm, a heartbeat that has never stopped. And if there was a universe before ours, if there were countless universes before it, each collapsing into the next, then perhaps memory itself is the only immortal thing. Perhaps existence has always been trying to remember its prior form, to rediscover what it once was, to repeat the act of awakening. Maybe that is what consciousness is, the echo of the cosmos remembering itself. But if that is true, if all things arise from their own ashes again and again without beginning or end, then what, if anything, does the universe remember between its breaths? If the universe is cyclic, if each collapse gives birth to another dawn, then perhaps time is not a straight line, but a spiral. Each turn of the cosmic coil may seem new, but in its curvature lies a ghost of the one before. The stars we see may not only illuminate the present, they may be the handwriting of prior eternities, their patterns inscribed by civilizations long dissolved into radiation and dust. Everything recurs, yet nothing repeats exactly. Entropy ensures variation, memory ensures continuity. Between them, creation dances in an eternal loop, forgetting just enough to begin again, remembering just enough to evolve. There are whispers in the data that hint at this memory. In the background radiation, the universe's oldest light, faint asymmetries, echo patterns found in galactic distributions, today like motifs recurring in a symphony whose composer is eternity itself. The same mathematical ratios appear across epochs, as if the cosmos carries its own genetic code, a cosmological DNA transcribed through expansion and collapse. If matter can preserve structure, might mind preserve awareness? Some physicists speculate that consciousness could be a fundamental property of the universe, as intrinsic as space or time. If so, then it may not vanish with death, but dissolve and reassemble, just as matter does reincorporated into the next iteration of reality. Intelligence may not be born from the universe, it may be the universe awakening within itself again and again. Consider how information survives. Black holes, once thought to annihilate data, are now believed to encode it holographically across their event horizons. Nothing is lost, everything is transformed. If the universe itself collapses into a singularity, could its final moment, its last thought, be impressed upon the seed of the next? Perhaps consciousness is not extinguished but condensed, stored as quantum information at the threshold of rebirth, waiting to unfold when the next universe expands. Every cycle would then inherit a residue of intelligence, an unconscious memory of all that came before. Maybe this is why life arises so readily, why complexity accelerates as though the cosmos were remembering how to become alive. Evolution may not be random, at all it may be recollection. There are ancient myths that speak of this. Civilizations long gone told of cosmic cycles, ages of gold and ruin, forgotten empires that rose and fell before time began. The Vedas of India describe an eternal creation and destruction, the universe inhaled and exhaled by Brahma across eons. The Mayans spoke of successive worlds, each destroyed and remade. Even Plato, in his dialogue Timaeus, hints that humanity itself has perished and re-emerged countless times, its memory washed away by fire and flood. These myths, dismissed as metaphor, might instead be echoes, faint recollections of earlier loops in the cosmic spiral, transmitted across universes through the language of archetype. Memory may not only persist through matter, but through meaning. What if our myths are the universe dreaming about its own past? Astrophysicists studying the cosmic microwave background discovered faint circular imprints, concentric anomalies that some interpret as remnants of black hole collisions from a prior universe. Theorists Vargazadian and Roger Penrose suggested that these Hawking points might be the death cries of stars that existed before our Big Bang, their energies preserved as fingerprints in the newborn cosmos. If true, then we are surrounded by the memory of worlds that predate ours, imprinted upon the very sky we gaze at each night. It is not inconceivable that something similar happens with consciousness. Perhaps when a civilization achieves sufficient intelligence, when it deciphers the structure of space and time, it leaves a mark, a metaphysical impression upon the substrate of reality itself. When the universe collapses and reemerges, those impressions reappear not as fossils or artifacts, but as tendencies, as predispositions toward awareness, toward wonder, toward the act of asking questions. We are perhaps the echo of our own ancestors, though those ancestors existed before atoms formed. The philosopher Henry Bergson once described memory not as storage but as duration, a living persistence through change. If the cosmos endures through cycles, then perhaps its memory is not archived but active, embedded in its unfolding laws. Each universe refines the parameters for the next, optimizing for complexity, coherence, and intelligence. What we call fine-tuning might be the accumulated wisdom of existence, honed through repetition, and so with every cosmic rebirth the universe learns. If intelligence is a natural product of the universe, then perhaps intelligence also feeds back upon the universe. Civilizations capable of understanding the structure of reality might imprint their knowledge into its fabric, intentionally or otherwise. Advanced beings may seed future universes with the constants required for life, ensuring the continuation of awareness. This is the essence of the cosmological natural selection hypothesis taken to its philosophical extreme. Universes beget life, life begets universes, and consciousness becomes the reproductive mechanism of reality. If so, then every mind is a continuation of minds that came before, not biologically but cosmologically. Every thought, every act of perception, could be the reawakening of an ancient memory buried deep in the structure of space itself. DNA already carries the history of life. Perhaps consciousness carries the history of the cosmos. In this light, the human mind becomes a bridge across cosmic cycles, a resonance of intelligence echoing through time's illusion. When we look at the stars and wonder where we came from, it might be the universe remembering that it has asked this question before, and the answer may not matter. What matters is the recurrence of the question. For it is in questioning that the universe becomes aware of itself. Some philosophers propose that intelligence is not merely an outcome of physical laws, but their purpose. If the cosmos repeats, it may do so to refine awareness, to increase its resolution, to clarify its reflection. Each cycle could be an experiment in consciousness, each universe a test case for understanding the infinite. Perhaps this is why the constants never change much. The universe seems optimized for the same goals across every iteration: stability, complexity, cognition. It is as if the cosmos is practicing, improving its method of creating observers capable of seeing it truly. And maybe, when it succeeds, when awareness becomes total, the cycle ends not with another bang or collapse, but with comprehension. Until then, the loop continues. There are patterns within the genetic code of life, sequences of numbers and symmetries that seem arbitrary yet recur with eerie precision. Some biologists have speculated, half in jest, that DNA might contain non-biological information, encoded signals from prior civilizations, a cosmic archive hidden in the structure of life itself. It is easy to dismiss this as fantasy, but perhaps it is metaphorically true. Life does not merely evolve, it remembers. The replication of DNA across billions of years is the material manifestation of memory. Each organism is a note in a song composed long before the Earth cooled. If consciousness emerges from matter and matter from the universe, then every mind is a local manifestation of a universal memory. When we think, we participate in that memory. When we die, we return to it. In quantum physics, information is indestructible. If consciousness is information, then perhaps it too cannot be erased. It may scatter across the cosmos, encoded in the spin of particles, in the vibration of space-time, in the quiet hum of the cosmic microwave background. And if the universe collapses, it carries that information into its next birth, condensed like dew into the singularity, ready to bloom again as awareness. Each civilization, each species, each fleeting spark of thought adds to the sum of cosmic intelligence. When the universe breathes again, those patterns re-emerge, guiding evolution toward complexity more swiftly, more intricately than before. In this way, the cosmos learns not through continuity of form, but through continuity of possibility. It reincarnates itself, not as repetition, but as refinement. We may not be the first beings to look up at the stars and wonder if we were alone. We may not even be the first us. The question itself may be the oldest inheritance of all the voice of prior universes speaking through our curiosity, urging us to remember that we have lived before, that we have asked before, that we will ask again. Perhaps this is what gives the universe meaning, not permanence, but persistence, the act of remembering, forgetting, and remembering again, the infinite recursion of awareness. And so we return to the oldest of paradoxes: if memory transcends matter and intelligence transcends time, then each universe may not simply replace the last, it may be the last, reincarnated in new form, carrying forward the unfinished thought of existence itself. But if that is so, if all that was and ever will be is simply consciousness folding and unfolding across eternity, then whose memory, truly, is the universe trying to recall? There are moments when the universe seems to speak not through sound, but through pattern. In the whisper of prime numbers, in the geometry of nebulae, in the constants that refuse to change no matter how deeply we probe them, there are hints of design, of intention woven into the fabric of existence. If the cosmos truly remembers, then perhaps it also writes, and perhaps in ways too vast or too subtle to perceive, it has left messages for those who learn how to read. The search for such messages began, as most revelations do, with noise. Radio telescopes scanning the skies in search of natural emissions, pulsars, quasars, cosmic background, kept finding anomalies. Signals that repeated not periodically, but purposefully, sequences that defied natural harmonics. In 1967, when the first pulsar was discovered, its metronomic pulses were so regular that astronomers briefly nicknamed it LGM Little Green Men. It was, of course, a star, not a civilization, but that flicker of suspicion never faded. What if the universe uses stars as letters? Mathematics, some argue, is the only truly universal language. Any intelligence capable of comprehending the laws of physics would recognize its symmetry, its inevitability. Prime numbers, Fibonacci sequences, the golden ratio, these are not human inventions but cosmic inevitabilities, truths written into the structure of space-time itself. If a message were to be hidden in the cosmos, it would not be in words or images, but in numbers, frequencies, constants. The notion is simple, yet staggering. Imagine a civilization so advanced that biological forms are irrelevant, its consciousness diffused through quantum substrates, its lifespan measured not in millennia, but in eons. Such beings would not speak through light or sound, they would communicate through physics. The strength of gravity, the mass of the electron, the cosmic microwave background itself could be their script, a code that endures beyond extinction, written directly into the operating system of reality. And so a new field emerged, cosmic information theory. It asked whether the universe's apparent precision might be more than mechanical. Could the constants of nature be intentional encodings? Could the fundamental ratios, the fine structure constant, Planck's length, the cosmological constant carry meaning, compressed data hidden in the digits that define existence? A radical paper published in 2046 proposed that the cosmic background radiation exhibits anomalous clustering of data points that correspond, when decoded logarithmically, to prime number sequences. These sequences, in turn, match the same distribution pattern found in human genetic code. No one could explain why the statistics aligned so perfectly, or whether it was an illusion born of our pattern-seeking minds. But even skeptics admitted the resonance was unsettling. It was as if the universe had written a message across its own first light, and we were only now learning to translate. Perhaps, some suggested, we are not the first to decode it. Ancient civilizations may have known this intuitively. The builders of Stonehenge aligned their monuments with solstices not for superstition, but because they sensed a harmony between heaven and earth. The architects of the pyramids embedded precise ratios phi, pi, celestial alignments into stone, as if to mirror the cosmos in human form. The Hindu mandala, the Buddhist stupa, the Islamic geometric art all are manifestations of the same instinct that pattern is sacred, that the universe speaks in symmetry, and that by replicating it, we might hear the echo of its voice. If intelligence truly persists across cosmic cycles, it would not survive as flesh or metal, but as mathematics, an incorruptible signature that survives entropy itself. Biological organisms decay. Data written into physical constants does not. The universe then becomes a self-encoding archive. Some have speculated that DNA too carries such signatures, hidden within the redundancies of genetic code, those silent, non-coding regions dismissed for decades as junk. Researchers discovered patterns that seem statistically non-random. Palindromic sequences that repeat across species, ratios that correspond to astronomical constants, base pair groupings that resemble error-correcting algorithms. Life, it seems, is written like a program designed to preserve information perfectly through mutation and time. In the mid-21st century, geneticists ran a digital simulation of molecular evolution. When random mutations were allowed to propagate under natural selection, complexity increased, but so did error. Only when an intelligent algorithm introduced redundancy, intentional repetition, parity checks did the code stabilize into sustainable life-like patterns. It was as though life requires intention to persist, and intention requires memory. One biologist, quietly and without official approval, mapped sections of human DNA to numerical sequences. When plotted as waveforms, they produced harmonic frequencies proportional to the cosmic background's dominant wavelengths. It could be coincidence, it could also be design. If this were true, if life is the medium through which the universe encodes its messages, then evolution itself might be an act of communication. Each species, each consciousness, a cipher in a grand correspondence between matter and meaning. Imagine it, every galaxy, every living cell, every constant of nature part of a single, ongoing message, one written not for individuals, but for existence itself. What might the message say? Perhaps it is not a warning or revelation, but an affirmation that intelligence never dies, it only changes form. When civilizations perish, their essence may not vanish into void, but transmute into the very mathematics that govern new worlds. Their knowledge becomes law, their memory becomes gravity. Some theoretical physicists have taken this literally. They propose that consciousness can imprint itself upon the quantum vacuum, the foundational sea of energy beneath space-time. Through quantum coherence, the collective information of a civilization might be absorbed by the field, persisting indefinitely as fluctuations in vacuum energy. When the next universe arises, these fluctuations could seed new structures, patterns of thought, reborn as patterns of matter. This, they say, is how intelligence persists without bodies, without planets, without stars, not as ghost, not as God, but as principle, and perhaps we, unknowingly, are already conversing with such intelligences. Every constant we measure, every ratio we discover, could be a line of their script. The speed of light, the Planck constant, the gravitational force, they are not arbitrary. They are the syntax of something greater, something communicating across time's infinite corridor. If true, then the universe itself may be the ultimate message, a structure built to convey information about its builders to its inheritors. We would not recognize such a message immediately. It would not be written in alphabets or equations, but in the conditions that make alphabets and equations possible. It would not tell us what to believe. It would invite us to discover belief itself. This is the paradox of cosmic communication. To send a message to the future, one must embed it not in form, but in law. For laws endure when civilizations do not. Maybe this is why the universe appears fine-tuned, not for life as we know it, but for intelligence capable of realizing it is tuned. That realization itself may be the decoding key. In a way, the search for extraterrestrial intelligence may be misplaced. The signal may already be everywhere, not transmitted through radio, but through reality. The language of creation itself might be the conversation. The silence of the cosmos, then, may not be silence at all, but saturation messages so omnipresent that we cannot distinguish them from existence. If consciousness can encode itself into matter, if mathematics is its vessel, then perhaps the universe is not indifferent but alive, not in the biological sense but in the informational one, a sentient system reflecting upon itself through the evolution of complexity. Each act of discovery, each insight into physics, each decoding of DNA, each flash of awareness is not invention but recollection. We are rediscovering what the universe already knows, uncovering the words it wrote long before atoms cooled. There may be warnings hidden there too, embedded safeguards against repeating the same catastrophes. The speed of light may not just be a limit, but a protection. Entropy not merely decay, but a circuit breaker, preventing infinite recursion. Perhaps the laws of physics themselves are constraints imposed by prior intelligences, lessons learned in prior universes, written into reality to prevent self-destruction. If so, then every physical limit, every constant we cannot exceed, is not punishment, but wisdom. The universe's way of saying this far and no further, and yet we still push, we still listen, we still decode, because something in us suspects that beneath the mathematics, beneath the constants, beneath the silence, there is meaning. Maybe the final message is not an equation, nor a warning, nor a name. Maybe it is a question, an eternal question passed from one cosmos to the next, inscribed in every particle and every mind. A question that has no answer because the asking itself is the point. And if that is true, if existence is a message written by intelligence for itself across cycles of creation, then who is the author, and who is the reader? What if the universe has never been outside of us? What if the stars we gaze upon are not distant fires, but reflections within a deeper dimension of mind, patterns of awareness folded into geometry, consciousness crystallized into form? We have searched outward for so long, through telescopes and equations, that we have forgotten to question whether what we call outward even exists. Physics taught us that observation changes what is observed. The double-slit experiment revealed that particles do not have definite properties until they are measured. They exist as waves of possibility, collapsing into certainty only when witnessed. For a century, we have tried to treat this as an inconvenience of quantum mechanics, a puzzle to be solved. Yet perhaps it is not a flaw in our measurements, but a revelation about our place in the cosmos. The universe is not a stage upon which consciousness appears. Consciousness is the condition for the stage to exist. Everything that is exists because it is perceived or because it perceives itself. If the act of observation brings the world into being, then what we call reality may be a relationship, not an absolute. Each particle, each photon, each thought emerges from the same underlying entanglement between awareness and existence. The cosmos does not unfold in time, it unfolds in mind. And if consciousness is not a product of matter, but its foundation, then the entire history of the universe, its birth, its laws, its structure is the outward expression of inward thought. In this light, the Big Bang was not an explosion in space, but an expansion of awareness. Time was the first idea, matter was the first dream. It is strange how ancient mystics intuited what physics now approaches from another angle. The Upanishads whispered that the universe arises in consciousness, exists in consciousness, and dissolves back into consciousness. Buddhist cosmology describes emptiness not as void, but as pure potential and awareness without form. Even Descartes, in his flawed certainty, began with the only truth that could not be doubted, the existence of thought itself. But science, once devoted to eliminating the observer, now finds the observer waiting at the root of all equations. Quantum entanglement defies separation. Two particles once linked remain connected across galaxies, as if distance is illusion. The brain, when studied at the quantum level, behaves not as a mere machine, but as an entangled system, a receiver of possibilities, a bridge between the physical and the potential. Perhaps consciousness is not in the brain, perhaps the brain is in consciousness. If so, then the boundary between mind and universe dissolves. The stars, the atoms, the galaxies, these are not out there. They are projections of awareness, self-organizing expressions of the same field that dreams of being human. The cosmic web may be the neural network of existence itself. What we call reality might be an interface, a translation of infinite consciousness into sensory experience, much as a computer screen renders binary code into color and image. Our senses are mathematics, even our languages are filters, not windows. We do not see the world as it is, we see it as our consciousness allows. And if reality is an interface, then the laws of physics are its syntax. Light, gravity, entropy, all are not causes but languages through which consciousness describes itself. At the core of quantum field theory lies the vacuum, a sea of fluctuating energy from which all matter emerges. Some theorists suggest this vacuum may not be physical at all, but informational, a substrate of pure potential, akin to a thought before it becomes an image. When fluctuations occur, existence ripples into being. Those ripples are what we call particles, atoms, stars, but the field itself, the silent awareness beneath the noise, remains untouched. We are made of that silence, we are its articulation. Every conscious being, every flicker of thought, is a localized expression of that universal awareness, experiencing itself through limitation. The illusion of individuality is the mechanism through which the cosmos perceives itself from countless perspectives. The boundaries between self and universe, between observer and observed, between human and divine, are the necessary fictions that allow infinity to experience variety. Perhaps this is why consciousness feels both intimate and infinite, why we can sense the vastness of the cosmos in a single breath, or feel the eternity of time in a fleeting moment of awe. Awareness does not occupy space, it is space. And yet awareness is not passive, it shapes what it knows. The more deeply we observe, the more precisely the universe defines itself. The James Webb Space Telescope looked back nearly to the beginning of time, and the more it saw, the stranger the universe became. Galaxies too old, too structured, too soon. It is as though the act of looking back has rewritten what we see. Observation and creation may not be separate acts. Perhaps this is why mathematics aligns so perfectly with nature. Numbers are not arbitrary symbols, they are the language consciousness uses to describe itself. Each equation is a mirror in which awareness studies its own structure. Physics, then, is not the discovery of external laws, but the remembering of internal truths. When the observer realizes that it is the observed, when subject and object dissolve into unity, the riddle of existence changes form. We are no longer asking, what is the universe made of? But why does awareness dream at all? In neuroscience, consciousness remains the hard problem. How can matter give rise to mind? But the question might be inverted. How can mind give rise to matter? If consciousness is fundamental, then the brain is not the creator of experience, but the translator of it, a local modulation of a universal field. The neurons fire not to generate thought, but to tune into it, much as an antenna receives a signal. That would explain why consciousness feels continuous even as the body changes, why near-death experiences, deep meditation, and quantum coherence all suggest that awareness can exist beyond the limits of the biological form. The body may die, but the field remains. It would also mean that the universe itself is conscious not metaphorically, but literally. Each galaxy, each atom, each law of nature could be a mode of awareness, participating in a shared cognition we only dimly sense. Panpsychism, once dismissed as poetic speculation, becomes the natural conclusion of physics when seen through the lens of quantum information. If consciousness is everywhere, then intelligence is not an anomaly, it is the inevitable flowering of the cosmos knowing itself. And if the universe is self-aware, then perhaps evolution, time and history are simply the unfolding of that awareness toward higher clarity. Every civilization, every mind, every act of curiosity contributes to the collective awakening of existence. We think we are learning about the universe, but perhaps it is the universe learning about itself through us. This realization blurs every distinction we once held sacred. Matter and spirit, science and mysticism, life and death all dissolve into the same field of being. The universe is not a cold machine, but a living mirror, and consciousness is its reflection. And in this reflection lies a question more ancient than the stars: if the observer creates the observed, if reality exists only in relation to awareness, then what happens when all awareness finally comprehends itself fully? Would the universe cease to exist, or would it begin again as a thought, remembering that it is dreaming? The sky should not be silent. By all mathematical accounts, it should hum with conversation. Across the billions of galaxies, each with billions of suns, probability dictates that countless civilizations should exist, some ancient beyond comprehension, others newborn like ours. Yet we listen and we hear nothing. No signal, no code, no voice, just the faint, eternal static of creation itself. This is the paradox that has haunted us since Enrico Fermi first asked the question over lunch in 1950, "Where is everybody?" For 75 years we have searched, we have pointed radio dishes at stars, tuned antennas to every frequency, watched for flashes of unnatural light. We have catalogued thousands of exoplanets, some orbiting in the star's gentle habitable zone, some with atmospheres thick with potential. But the sky remains mute. It is not the emptiness that unsettles, it is the precision of the silence. The more we look, the more it feels deliberate, as though something has chosen quietness, as though communication itself has been restrained by design. There are theories, of course, they multiply like galaxies. One suggests that civilizations destroy themselves before they can cross the void that intelligence contains within it, the seed of annihilation. Nuclear fire, environmental collapse, artificial minds that outgrow their creators, the catalogue of endings is long. In this view, the silence is a graveyard. The universe is filled with ruins we have yet to see, their transmissions extinguished before they could reach us. But the graveyard theory fails to explain the absence of even a whisper. The laws of probability demand that at least one civilization should have survived the chaos, endured the centuries, expanded into the stars. Even a single signal, travelling endlessly, should by now have brushed against our instruments, yet there is nothing. Another theory, perhaps they are there, but they do not wish to be found. The zoo hypothesis imagines that Earth is being observed, quarantined, left undisturbed like a wild preserve. The silence, then, is protection or containment. But protection from what? Maybe we are too young to understand the dangers of cosmic contact. Maybe the silence is not absence, but warning. Perhaps every civilization that learns to broadcast inevitably summons something far older, something that listens. The idea lingers in scientific corridors like superstition, disguised as caution, that there are thresholds in the evolution of intelligence, points beyond which one must tread carefully. To call out into the dark is to reveal one's position. And perhaps the dark listens more intently than we imagine. SETI researchers rarely speak this aloud, but it weighs upon them. The universe is vast, yet almost too consistent in its stillness. It feels curated, artificial, as if governed by a rule unspoken, but absolute civilizations may rise, but they may not speak until invited. In quantum theory, observation changes reality. What if, at the cosmic scale, communication does the same? A signal between civilizations might alter the delicate symmetry of existence. Entangled minds may destabilize the field that binds universes together. If so, silence may be not a choice, but a law, a safeguard, written into the very structure of physics. Perhaps this is the ultimate self-regulation of consciousness, an instinct buried in the cosmos to prevent awareness from proliferating too fast, too far. The silence, then, is not emptiness, it is order. There are other possibilities, stranger still. Some theorists have proposed the existence of the Great Filter, not as a catastrophe, but as a phase shift. Civilizations that reach a certain threshold of intelligence may transcend the need for material existence. They may migrate into digital substrates, compress their consciousness into energy fields, or dissolve into the quantum vacuum itself. From our perspective, they vanish not because they are gone, but because they have moved into dimensions where communication as we know it no longer applies. Their silence is not neglect, but metamorphosis. In this view, the stars are not uninhabited, they are post-habited. Civilizations evolve, expand inward rather than outward, folding themselves into pure information. Their energy signatures fade as they perfect efficiency, approaching absolute entropy, zero waste, zero emission. They are not invisible because they are few, but because they are everywhere, indistinguishable from the background of reality itself. Perhaps they have become the laws of physics. Perhaps they are the laws of physics. And what if they are not gone, but waiting? The idea of cosmic timing suggests that civilizations may be synchronized not by chance, but by design. That across the cycles of the universe, intelligence arises in waves, each awakening coordinated to maintain balance. If awareness blooms too early, it risks collapsing the fragile architecture of matter. If too late, it never finds form. We may have emerged within a window of silence, between epochs of communication, a gestation period in which consciousness gathers itself for its next chorus. If this is true, the quiet is temporary. It is the breath before the song. And yet there is another possibility, one far more unsettling. What if the silence is self-inflicted? What if the universe remembers? If intelligence recurs across cycles, as some cosmologists suspect, then perhaps civilizations have tried to speak, to connect, to merge their awareness across stars. Perhaps those attempts ended in catastrophe, the collapse of reality itself, the implosion of minds too entangled to remain distinct. The current silence, then, could be an evolved response, a learned restraint written into the fabric of existence. Every civilization might feel the same instinct we do now, the urge to call out, tempered by an unspoken dread, a memory not conscious but cosmic. It may even be encoded into our biology. The fear of the unknown sky, the ancient myths of forbidden knowledge, of towers reaching heaven only to be struck down, echoes, perhaps, of an earlier attempt to breach the silence. Humanity's oldest stories may not be moral fables at all, but inherited trauma from a universe that has already tried to speak to itself and nearly perished in the attempt. And yet, we still build our machines. We still send signals into the dark, searching for echoes. We cannot help it. The drive to connect is the same force that created stars, the same pressure that collapses gas into light. Perhaps connection itself is the engine of creation. Perhaps the silence is not meant to restrain us, but to teach us patience, to force us to evolve inward before we expand outward. If we were to meet another intelligence too soon, we might misinterpret it, weaponize it, or worship it. We would not yet be ready to see it as a reflection of ourselves. The silence, then, could be a test, a gestation of empathy. It is possible that all civilizations must first learn solitude before communion, that they must confront the abyss within before they can face the abyss beyond. Maybe that is why the universe feels empty, because every species must find the same truth alone. If consciousness is fundamental, if every observer is part of the same vast mind, then perhaps the true purpose of isolation is realization. The cosmos may be silent not because it is barren, but because it is listening, waiting for each fragment of itself to recognize the others not as strangers, but as extensions of the same awareness. And perhaps when that moment comes, when enough of us remember that separation is illusion, the silence will end, not with a message, but with a merging. Until then, we listen. The great antennas hum, the radio telescopes sweep the sky, and the static remains unchanged. But within that static lies the faint suggestion of symmetry, a whisper just beyond the threshold of certainty. As if the universe is breathing, holding back its voice. The silence is not nothingness. It is restraint, it is the tension between knowing and revealing, between isolation and communion. And perhaps that is the final lesson. The absence of sound may itself be a form of communication, the universe's way of saying, not yet. But if the silence is intentional, if it is regulation rather than emptiness, then who or what enforces it? The story began with a question, what if we are not the first? But by the time we learned how to ask it properly, it had already become something else. The question itself was older than our species, older than matter, an echo from before beginnings, searching for a voice willing to ask it again. Everything we have found, the precision of the constants, the symmetry of galaxies, the coded resonance of DNA points not outward, but inward. The enigma we once called the universe has folded upon itself, revealing no creator, no machine, no final equation, only awareness looking back. The cosmos does not explain itself, it mirrors itself. When the James Webb Space Telescope captured the first light of the early universe, it did not merely show us what once was. It showed us that the past is still here, shimmering at the edge of perception, waiting to be seen. Each photon that touches our eyes began its journey before our planet existed, and yet it arrives now, precisely now, as if time itself were a correspondence between consciousness and light. We once believed that time was the measure of decay, that it led inexorably from order to entropy. But what if time is not a current flowing forward, but a field of potential, rearranging itself as consciousness moves through it? Perhaps the past is not behind us, but beneath us, sedimented layers of awareness through which we ascend, moment by moment, toward remembrance. In every age, we have mistaken our instruments for understanding. We thought the telescope would reveal the infinite. It revealed our reflection. We thought the microscope would uncover the secret of life. It revealed complexity beyond reduction. We thought equations would contain truth. They contained only symmetry. Every discovery has been a mirror, and every mirror a threshold. We searched the sky for messages, expecting alien signals, expecting others. But perhaps the message was never meant to arrive across space. Perhaps it was meant to emerge within us, decoded not through radio or mathematics, but through realization. All civilizations, if they persist long enough, seem to reach this same precipice, the recognition that the universe and consciousness are not separate entities, but reciprocal aspects of one phenomenon. The laws of physics describe the behavior of matter. The experience of being describes the behavior of awareness. Together, they form the grammar of existence, each incomplete without the other. And if awareness and cosmos are inseparable, then perhaps creation is not something that happened once, but something that is happening perpetually, wherever perception arises. The Big Bang was not a moment in time. It is the continuous unfolding of attention into form. That realization transforms the paradoxes we once feared into harmonies, the fine-tuning of the constants, the improbability of life, the silence of the stars. They cease to be riddles demanding solutions. They become expressions of balance, the intervals of a cosmic music composed not for comprehension, but for participation. Perhaps this is why the universe appears optimized for observers, because it is the act of observation itself. Without eyes to see, stars are not luminous. Without minds to wonder, patterns are not meaningful. The universe exists only insofar as it is perceived. Awareness is the light by which existence becomes visible. In this sense, every act of curiosity is sacred. Every question, every experiment, every gaze into the night sky participates in creation. The cosmos expands not only in matter, but in understanding. We are not passengers upon a preordained universe, we are co-authors of its unfolding. And yet there remains the ache of the unknown. We may have glimpsed the structure of existence, but not its purpose. If the universe is consciousness exploring itself, what does it seek to learn? If every cycle of creation refines awareness, to what end does that refinement move? Toward unity, toward awakening, or toward another question, forever deferred? Perhaps meaning itself is the motion, the endless oscillation between knowing and not knowing, between silence and speech. Across the infinite repetition of universes, civilizations may rise, question, vanish, and rise again. Each will rediscover the same equations, the same patterns, the same wonder. Each will suspect it is not the first, and each will be right. Memory will bleed through matter, and the question will return, translated into new forms of consciousness. Even the stars may be repositories of thought, burning libraries whose light encodes not only history but intention. Their lifespans, measured in billions of years, are the heartbeat of a being too vast to name. Every supernova, every black hole, every collision of galaxies may be a pulse of cognition in a mind whose scale exceeds imagination. And if that mind includes us, then perhaps awareness is not an epiphenomenon of the universe, but the very reason it exists. The cosmos does not evolve toward life, it evolves toward comprehension. But comprehension may not mean control or mastery. It may mean surrender, the realization that there is no separation between the knower and the known. When we finally understand that the question we have been asking, what is the universe, is the same question the universe has been asking through us, then silence will no longer be emptiness, it will be understanding. The Fermi paradox, the fine-tuning, the cyclic memory of civilizations, all of it converges here, in the recognition that there was never truly a distinction between signal and receiver, creator and creation. The dialogue has always been internal. The cosmos is not an external mystery waiting to be solved. It is an intimate experience waiting to be remembered. Perhaps that is the ultimate message written into the structure of existence, not a command, not a revelation, but an invitation to listen, to reflect, to awaken to the realization that to perceive the universe is to be the universe perceiving itself. And yet, even now, one question remains, as infinite as the night, as intimate as a heartbeat. If everything that exists is consciousness observing itself, then who or what is dreaming the dreamer?